Over the last couple of years, security and privacy have emerged as two of the biggest concerns for the tech industry. To protect users' data, tech companies have had to invest a lot of resources against an ever-increasing range of software attacks. However, no system can truly be secure if the underlying hardware is vulnerable. Traditional computer architects, the people who design these CPUs, have been ruled by a single directive, that of performance. As a result, critical security considerations were often just swept under the rug. The traditional way of isolating process boiled down to a single feature: virtual memory. While virtual memory gives a strong abstraction, it is insufficient to protect against a range of attacks known as side-channel attacks. These are attacks which use the side effects of computation to leak information. While side-channel attacks have been known for quite a while, they could normally be mitigated through some sort of software restructuring or software rewriting. As a result, the hardware industry was very happy to shift the blame onto software developers and continue on their path of seeking performance. It was no wonder then that when Meltdown and Spectre introduced the world to speculative side-channel attacks, most modern CPUs were found to be woefully inadequate. As variants of these attacks emerged over the next year, hardware and software manufacturers were all required to make patches to their code to mitigate their vulnerabilities. However, there was a difference this time. Because the underlying hardware was not suitable for this sort of patches, these patches often introduced an unacceptable amount of overhead. My work on secure performant computers tries to imagine what computers would look like if built from the ground up with security as a primary concern, while also incorporating other necessary features such as power consumption, resource sharing, and costs. We at Parsa are focusing on redesigning the pipeline, the network on chip through which processors communicate with each other, and other shared resources. Our insights are born of existing attacks such as Mother Spectre, which we was working on in the last year. These attacks are still not mitigated by the state-of-the-art cache defenses which have emerged in the last 6 months. Hopefully, we'll be able to reach a state where the hardware is just as secure as the software needs it to be. Thank you.